Okay, so welcome. I'm doing my talk about Makepad, which is my next idea, project. 5 years ago, I was working on Cloud9 IDE, and we're building UIs with HTML and CSS. But we were building UIs that I don't think HTML was designed for. It's application, IDEs, design tools, that kind of stuff. So as WebGL was very early in that stage, it just barely worked on some places, I saw an opportunity to explore how to do UIs on the web without HTML and CSS. And it took me 6 generations of file new, literally, and 5 years to even get to the point that things are acceptable, that the way you write things is not that much more complicated than HTML, or actually more simple, but still being very fast. So this whole thing that you see on the screen is Makepad. It's my new IDE. It's a code editor, live running program, and every single thing is written in WebGL. So every pixel on the screen is drawn using WebGL. And I'm going to give you a tour of how that works and why I did that. So why would you want to use WebGL? Because WebGL is actually, if you look at the API, and I challenge you to go look it up and see what it looks like, it's incredibly low level. It's very, very low level. It's so low level that it's you can't actually work with it without layering a framework on top, like 3JS or some other library that sits on top of the API, because it's very verbose. Even simple things like drawing a rectangle are a page of code. And but what WebGL exposes, why is WebGL cool? It exposes the programmability of the GPU, right? So everybody here has a phone and a laptop, and these things come with CPUs, which have 1 to 8 cores, and GPUs, which have 10 to 1,000 cores, right? A lot of Moore's law over the last 10 years has been pushed into the GPU. But if you don't use the GPU for anything else than, I don't know, compositing some textures, you're missing out on essentially the last decade of Moore's law. And so what I saw was that if you could expose the programmability of the GPU in a way that JavaScript developers can just do it without going insane, maybe there's something there. So I want to show you what that means. So here, for instance, is a little demo. I have a slider. These are 4 simple sliders. They also work multi-touch with multi-fingers, which is really nice. But just show the speed of spawn up. So now we have 40 sliders. Let's give them some random position. Make them a bit smaller. 400 sliders. That's still fast. There's still sliders. Every single thing is still a widget. Okay, let's do 4,000 sliders. Okay, it's still very snappy, no problem. Let's make them a bit smaller. So it's 40,000 sliders. Well, still doing all right. So this is a domain. If you try that with the DOM API or something like that, it doesn't matter if you do React. React won't help you. It will be unusably slow. So one of the things that I was focused on coming out of Cloud9 was how to do a code editor, right? How do you do a high-performance code editor in a browser? And the answer is to make the API simpler and just have JavaScript essentially write arrays that you just pass to the GPU entirely. So another thing is, one of my focuses is to make programming more fun. And one of the ways to make programming more fun is to expose that compute for creative coding, for instance. Here's a little fractal tree. Let's make it stop dropping the leaves. So here's a little fractal tree that actually warps its leaves with the mouse. The nice thing about why this is fast and this runs on your phone, you can do this on your iPhone, is because it's executed in parallel entirely on the GPU. And the way you do that is you write a little bit of JavaScript. Instead of you writing GLSL, which is what the GPU with WebGL executes, which is a C-like language, I try to make it programmable entirely from JavaScript. So you write a pixel function or a vertex function. Those are the little methods that are called on the GPU. The pixel function is called for every pixel on the screen, and the vertex function is called for the geometry that you pass to the GPU, so triangles or rectangles or stuff like that. So the vertex stuff is used for rotations and transformations of matrices. The pixel stuff is used to give things color. And the nice thing about it is if you can write those functions in JavaScript and compose them in JavaScript, and by composing I mean have different methods that you can override and call other methods, you can start to program the GPU using JavaScript. I'll go into that a little bit more in a bit with this little demo. Somebody asked me on Twitter, or somebody asked a question on Twitter like, hey, how can I animate 50,000 circles? It's like, okay, that sounds like a job for Makepad. Let's see how much work it is. So here you draw 50,000 circles. Here you can see the code. So you pass in an index, x, y, a color. The color is set to random right now, a width and a height. And this draw circle primitive, if you look at Canvas API, you get circle, ellipse, rect, that kind of stuff. With programmable GPU, those APIs become pluggable. So you can define your own code, that is your own drawing primitive, and include it on another class. So you have to think of it as a programmable canvas. So you define a shader that draws things. It could be anything, circles, rects, lines, and you include it on a class, and then it adds methods to that class. So draw circle is the method that my circle shader plugged onto the class. So it's sort of like a class, you nest a class in an outer class, and the nested class exposes methods on the inner class. Anyway, it's a construct that I came up with to make this really fast and actually composable. Because these methods, these drawing methods, are now no longer fixed primitives that are somewhere, stuck behind the big C++ engine, but can be pulled all the way to the front. Here, for instance, I compute the distance to your finger in the vertex shader to size a circle, right? That means that I can do 50,000 of them. If I have to make a for loop in JavaScript to do this, no way ever that you could get this at 60 frames a second. So that's the power. The power is to pass data through JavaScript to the GPU in an easy way. So I can say, hey, radius, right? I just define radius here. And I should be able to set radius here. Right? So now I'm passing it in from JavaScript, but that means that I can also, randomly modify it here. So essentially, what a decent chunk of my framework does is it maps data from JavaScript to the GPU automatically. If you had to do this in WebGL, essentially you're counting offsets in arrays, and then you're trying to match that to a shader. It's like essentially what compilers are designed to do, you don't get. You just have to count offsets. So if you add a variable, all of a sudden all your data structures change that you pass to the GPU, and you have to do all the work all over again, unless you automate it. So why WebGL? Because otherwise I don't know how to build this UI. I don't know how to build this code editor, and I don't know how to get to new areas in terms of data visualization. Because HTML, to me, is kind of sort of end of the road. I cannot move forward with it in terms of building applications. So it runs all in a web browser and on your mobile. If you Google this, Makepad, you should be able to open it on a decent iOS device. Because actually iOS devices like A9 or A10 are, the chip, are very close to where Intel and NVIDIA are. Very, very close. In terms of clocks per pixel, that means like how much power do I have per pixel? An iPhone beats an NVIDIA laptop. You just don't see it because nobody ever uses it that way, but I notice it very, very clearly. And in terms of CPU, these things are so fast. I mean, I think the new iPad Pro is faster than the new MacBook, the 12-inch, right? So low power, mobile chips are outperforming desktop chips. And you only start noticing it when you actually put pressure on the GPU. And another really cool thing, and I needed that for Makepad is entirely multi-threaded. So JavaScript is single-threaded, yes, but if you have workers, you can use multiple threads. The problem is you don't get any of the APIs, right? You're in a worker, you can only send messages to the main thread. You don't get any of the APIs. So Makepad is not just a library with a compiler that compiles JavaScript to the GPU. It's also sort of like a thread architecture in which the main thread processes messages from the worker. But I'll talk about that in a bit. This is just the overview. Type inferencing JavaScript to shaders. So shaders are fully typed. So that means that you don't have var x, you have float x or vec2 x. You have to know the type. The cool thing about it, if you look at code, you can often, so here you say let p is pause. If you know the type of pause, you know the type of p, right? You can have right-hand side propagate all the types. And the cool thing about it is that if you do that, then you can write shaders in JavaScript without too many hang-ups. You have to get to know a little bit the intricacies of it. So this code editor as well. So why do you want to write a code editor in WebGL? Because it's an AST code editor. And AST code editors are really cool. I'll show you. Here, for instance, I unfold and unfold an object. I don't know if any editor can do that. Or you can right-align your object keys. I have no idea. I have not seen an editor that does that. And the reason it can do this is because it cycles through the AST. And cycling through the AST is really cool. I'll show you that in a bit. Class composition, I talked about that a little bit. Of course, it has a complete layout engine, but it's a new kind of layout engine. But I'm not sure how much detail I can go. And then there's the main user interface. So this whole thing is written on its own framework. So the reason I can say this doesn't suck is because it does that, So it's my own sanity check. So multi-threading. The main browser thread, right, where everybody is doing their JavaScript, because how many people here have run JavaScript in a worker that does anything useful? One person. Okay, 2. All right. So in Makepad, the worker is the main thing. It runs everything. And one of the reasons I need that is because how can you else live code JavaScript in its own browser frame, right? This is a web browser. So if you make an infinite loop, your whole IDE crashes and burns if you don't have it running in a worker, right? So for having a live programming sandbox, running it in a worker is actually the only architecture that I know of outside of out-of-process iframes, but Google has informed me that my use case was not a use case for out-of-process iframes, so I kind of gave up on that. So essentially you have to reinvent all the web APIs in a worker, message-based. So that's been a large chunk of the 5 years, has been figuring out how to make those APIs that live in a worker be nice. And one of the cool things I can show you is, so here you see my 40,000 sliders that are happily scrolling. I'm going to resize this window, and here you see my worker resizing happily. It's like one worker is now doing 100% CPU, but the rest of my UI has no problem at all, right? If you do this in a browser and your program is busy, then your whole UI will come crashing down. So it actually has a lot of benefits. And the way I do this is I build command buffer trees. So the drawing API, this is like there's a WebGL Lite running in the worker that is constructed out of trees of commands, which are typed arrays, which just say draw this, draw that, draw that. And I hand them over without copying them from the worker to the main thread. So you can very, very quickly update draw commands. It's one of the ways that React was also thinking about doing multi-threading by essentially just diffing to the main thread. This is not diffing because I don't have to, but it just transfers command buffers. And the nice thing about it is that it's actually really, really fast. It's fast enough for a code editor. So type inferencing JavaScript, that's another really, really neat challenge. Because if you want to make shaders programmable in a way that you can read, like here, like here's the slider, I think. Hold on. So I'm now live coding the presentation slide. So this is This is the shader API. So if you've looked at shaders, essentially it's a program that's executed in parallel for your pixels, and it processes 4 vectors. Okay, now make a circle in that, right? Okay, well, I can do a length, right? Do a length. Okay, now anti-alias the edge. Oh, okay, you know, it gets harder and harder. Okay, now composite it with something else. Before you know it, you're doing a lot of math. And math is not easy often, especially not if you're trying to scale. So this is an attempt to make a shader API that looks like Canvas, but is running in parallel. So it's a functional version of a canvas. So for every pixel, I execute a full set of compositing operations and calculate the distance to different shapes. So that also means it doesn't really scale very well to a lot of shapes. It scales very well to, you know, maybe 10 shapes, but you can then draw 100,000 of those 10 shapes parameterized by data. So you can't draw 100,000 shapes in a shader. You pass data that draws 100,000 shapes, but every single one of those shapes can be composed out of 10 other shapes, which is actually kind of neat for data visualization. That's exactly what you need. You know, maybe you want some odd-looking little pie chart or something. You can do all of that. You can do hundreds of thousands of those things. So yeah, type inferring. So this is, if anybody has written a GLSL, I'm sorry that it didn't syntax highlight that thing on the right, but I was lazy. But on the left, you see the JavaScript, and on the right, you see the GLSL. So if anybody knows what C++ looks like after it's C-ified by the compiler, it essentially annotates types on functions for methods, for instance, right? So here you can see this.viewport type, and this is the argument type, vec2. So it essentially expands the types for all the arguments, so it annotates the function names, and then it can generate GLSL. The nice thing about it is that they're very similar. You can read both. It doesn't really help, though, because shaders are undebuggable horror shows. But at least, you know, there is a lot of similarity between the shader and the JavaScript. So if you know how to write shaders, you can learn this very quickly. And if you don't know, you have to learn a little bit about vectors and a little bit about math. But hopefully, this API fixes a lot of that. So the AST Code Editor has been an R&D project for a very long time. The nice thing I want to show you about the AST editor is that it allows you to, so this is actually JavaScript live reloading in the worker, right? I'm not doing some kind of special only updated color. I'm essentially sending it completely new source that I modified in the editor. So this is how fast JavaScript engines can hot reload code. So now, you know, that's one of the reasons that I hate compile stacks for JavaScript, because I think it's completely the wrong direction for the web and for developers. Here we have this hot reloading, awesome, super fast language, and what do? And you build a compiler for it. No, you should just leave it as is, because if you compile it from TypeScript, I'm going to challenge anybody who can, at 30 hertz, reload the TypeScript through a compiler. So this is what an AST editor allows you. It can do a symbolic editing of your AST. And in this case, I just only have a very stupid example, which is changing the color. But you can also have a visual layout editor, design tools that operate on the AST of the code. And the cool thing about it is that it's stuck to the code editor. So it doesn't break your formatting. It's like you know, the prettier thing that everybody's starting to use to format its JavaScript. This is fully integrated in the edit cycle. So the editor has its own live formatting prettier. That's actually, if somebody says, "Oh, your editor feels like a normal editor," that's like the biggest compliment ever to me, because making this thing not make you scream and throw your computer out the window was definitely a year of work or something. So the editor has things like, if you make a typo, this is a parse error that shows up. But if you do something like, this is a runtime error that's coming from the worker and is mapped into the editor. You know, there's those little things that are really, really hard to do. In Safari, I don't get proper call stacks, unfortunately, at last check, but at least in Chrome, this works. So We were at class composition. Yeah, so okay, you let go of HTML, you let go of CSS. You know, it's a brave new world, because everything you can come up with to do it, you can technically do. But is it easy, right? Is it composable? So for Makepad, I've kind of invented something, which is called a nested class. So because the primitives that you use to draw things are shaders, which are JavaScript classes, ES6 classes in this case, they compose onto other classes to expose draw commands. But how do you, the reason they compose onto it as well is because then I can take that component and include it in somewhere else, and then I can subclass the nested classes, right? So if you take a class, you know, a module, and you require class B at the top, the reference to that class is hidden in the closure of that module. So you can never reach in and change class B that is used by class A. So you're essentially, you wrapping that component makes it completely inaccessible to modify it from the outside. So if you compose classes onto each other, you can also do nested subclassing. So you can take a class and then subclass its inner classes just by essentially using a JavaScript object that sits as a child of the class. And that turns out to be really useful, because if you don't have CSS, how are you going to style things, right? We don't want to make Winamp in the 90s, because that's really, really easy. You're like, oh, shit, we're still in the 90s if you didn't actually think about how to compose these things. So yeah, I'm really looking forward to if anybody understands that part. So layout is actually another one of the things that I took a long time to do. Like, here's some buttons that are left aligned, here's a button that's right aligned. And all of the buttons are sized so they push down the text editor. There's no fixed layout. It's completely float layout. So things push each other to the side based on content size and that kind of stuff. I don't really want to go into too much detail there, because, yeah, it's just going to be too technical. So yeah. So it's a replacement for CSS. Instead of using sort of like an external property application system, I use class composition. And a nice thing about it is that it moves everything into the prototype chain. So hot reloading, what you've been seeing as I type, only really works if I don't do all the things that you should do whilst building up the class structure for the application. I'll show you in a bit what that means. So yeah, I made a little fake shop that has like a, you know, a little texture that shows you mouse activity. For me, it's, you know, this is a heat map, and you can add stuff to the cart and you can remove it. So this is all using the float layout, and hopefully it's actually very simple. So we'll see about it if people understand it. And the reason that it's so fast is that it's inside the draw flow. So everybody who's doing layout engines generally spawns up a structure in memory and then crunches it into a layout. With this, it's executed as you draw with look behind. And the reason that is nice is I can do this kind of stuff. Like, oh, this is a tree graph, but it's gigantic, right? And I think I hope you can see it, but the text is pushing the lines, right? If you try to do this in a DOM, you have to synchronously ask the DOM engine, like, where's my text? Because it doesn't know that, because it's running in another thread. That's why you get like all these reflow things. But if you lay out as you draw, I can just draw, and then I know where to put the line, because I already know that, because it's in the draw flow. So it sort of decomplects your layout engine. But you know, if you want to talk to me about that, I can talk about it for a very long time. Yeah, so the main UI, because of course the only real use case I have right now is this thing itself. I want to show you some features of the thing. So this is a little thing I did for a friend of mine at the UVA for his class. Essentially it's a little parser. And I was like, okay, how can you use Makepad to okay, what do we get? We get a console that actually is not like a browser console. I can actually log tens of thousands of lines to it per frame, and it doesn't die. It doesn't. You know how you're debugging and you're in an infinite loop and your browser console dies? That's when I really start yelling at it. So this actually is a multi-threaded console log that is actually very fast and can take an enormous amount of data. It's so much that I can write a parser and show every token that gets pulled through the parser and just dump the whole string in the log. So here you see a peg parser that you can see the parse flow in the editor. This is really just the call stack of a console.log visualized in the editor. So I thought that was kind of neat, because all of a sudden, printf debugging can be used for far larger data sets than you're used to. So yeah, I also made an audio editor. Here it is, it's a sample. And it has selection, and I can cut things. This was just a little test of, okay, so you built a code editor, can you now also do other media types in a way that it actually works? So this is a virtual viewport wave that, as I zoom in, it only draws like this area with a little bit around it. The scrolling runs in one thread, and the update windows to the side just make sure that there's always enough data. This is actually a really difficult problem, like, oh, let's make a multi-threaded data view. Most people just go, no. But if it's like the natural way to write things, that's kind of nice, right? So I tried to make that natural flow easy. Another is that I made a little packager. So this is actually a compressor. I was trying to get it in 64K, don't blame me. So you package it, and now you get a bare HTML file that is just the application that you have. So I made a little packager. I also made a trace packager. Trace packagers are a really bad idea, exceptionally bad idea actually, because what happens is it traces the call flow of everything in the worker and uses that as an index to throw everything that hasn't been executed out. It's kind of nice if you're trying to get a very small file, but you have to make sure you click every button if you do that, because if you don't trigger a code path, it will not end up in the executable. Then again, if you're trying to be JS1K or JS64K or whatever, then you don't care about that thing. And of course, how do I check that I'm not an idiot? Well, I force myself to use it myself. And hold on. Why is this not working? Oh God. Oh. That's why it's not working. My fake HTTPS decided to time out. So here's the thing in itself, right? It's the IDE in itself. And how do you modify things like that? So here's the tree widget, right? The tree widget. And you can now live code the tree widget in the IDE itself. So that is my test. Like, can I use it for the thing itself? Because that's the most complicated thing I've made so far. And yes, I can. I just don't have find replace yet. All right, so yeah, that's pretty much all I wanted to show you. I'm finishing the UI kit. I want that cool Gaussian blur behind dialogues that's up next, because you can do that with this render stack. You can do all those kinds of cool tricks. I'm going for more visual editors in the AST, because a color picker is cute, but you want to have UI designers and all that kind of stuff. And one of the big challenges is that how do you make an AST modifying a UI designer in a way nice? Because modifying ASTs is actually kind of crappy code, so I'm also investigating how to make AST APIs nicer. And it's going to be an online service on Makepad.io whenever I feel like it's ready. So right now I publish everything to GitHub Makepad. You can Google it, you can open it right now, you can take any code you want. I do Apache 2 or MIT. I really don't care, but I don't want to support you. So take that as a, because I have to do this, I'm alone making this, and there's a lot of, little things that are going on, but my goal is to make quick basic for the web, this thing where you go and play with code and easily share it. and focus on the fun of programming. Like, I'm currently working on an audio API, actually. Maybe people can start to collaborate. One makes this synthesizer, the other makes this drum kit, and then all of a sudden it puts together into something that works together. So, if you want to follow me, I rant a lot about, you know, positive and negative sides of the web. On Twitter, that's my handle. So yeah, I think I am right about on the mark. I'm at -2 minutes. It's nice if you program your own presentation and you can just make a little timer.